AI agents are getting good enough to sound convincing, and now the bottleneck is whether they can be trusted. This week's work points to the same shift from three angles: extracting reusable skills from experience, training deep research systems on fully synthetic tasks, and forcing autonomous research to prove every claim with evidence. In plain English, we're moving from agents that can answer to agents that can justify, remember, and reuse what they learned. Here's what actually works, what still breaks, and why the next leap in AI may depend less on scale and more on verification. Let's explore the first paper, From Raw Experience to Skill Consumption, a systematic study of model-generated agent skills. This Microsoft Research, Fudan University, and Shanghai Jiaotong University study systematically evaluates model-generated agent skills across the full lifecycle of raw experience generation, skill extraction, and skill consumption, using 5 domains, 6 target models, and 5 extractor models. Across AlfWorld, Spreadsheet Bench, SWE Bench Verified, SEAL, Zero, and BFCL v4, extracted skills improve downstream performance in 75% of extractor target pairs, but 25% still show negative transfer, with AlfWorld the most fragile domain at 47% negative cases. The paper shows that extraction quality is not a simple function of model strength. On Spreadsheet Bench, Gemini 3, 1 Flash Lite achieves the highest extraction efficacy, even though GPT-5-4 has the strongest baseline task score, and the same skill can transfer very differently across targets. A deeper analysis finds that the success to failure mix in the experience pool is domain dependent, that skill format itself is irrelevant, and that an LLM judge's unconstrained pairwise preference is only 46.4% accurate and falls to 15.8% on the hardest pairs. By contrast, a validated 3-dimension rubric failure mechanism encoding actionable specificity and high-risk action blacklist raises judge accuracy to 73.8% and, when converted into a meta-skill inserted into the extractor prompt, improves average downstream performance by 1.55 percentage points, while the naive plausibility rubric hurts by 0.59 points. Let's explore the second paper, Quest Training Frontier Deep Research Agents with Fully Synthetic Tasks. Quest, from The Ohio State University with Amazon AGI SF Lab contributors, is an open deep research agent family spanning 2B to 35B parameters that targets 3 coupled capabilities: fact-seeking, citation, grounding, and long-form report synthesis. The core novelty is a fully synthetic training pipeline, Quest 8K, built from rubric trees that convert web-synthesized tasks into verifiable rewards without human annotation, plus a structured context state that compresses search history into trusted, untrusted, and uncertain claims, so the agent can continue across long horizons. The training recipe combines mid-training, supervised fine-tuning, and GRPO-style reinforcement learning, while also using inline citations and a fact-checking reward. On 8 benchmarks, Quest 3.5B reaches 64.6 on BrowseComp, 30.7 on Mind2, Web2, 48.2 on Deep Research Bench, and 80.8 on Gaia, surpassing OpenAI Deep Research on Mind2, Web2, and Deep Research Bench, and matching or exceeding GPT-5 on GAIA. The paper also shows that even Quest 2B SFT remains surprisingly strong on fact-seeking tasks, but open-ended synthesis still benefits most from the full MT plus SFT plus RL recipe. Let's explore the third paper, ScientistOne Towards Human-Level Autonomous Research via Chain of Evidence. ScientistOne Towards Human-Level Autonomous Research via Chain of Evidence from Google Cloud AI Research argues that autonomous research systems fail not mainly on score quality, but on verifiability, and it introduces chain of evidence, so every citation, number, method, claim, and conclusion must trace to explicit evidence. The system's pipeline has 3 stages: a problem investigator that reads up to 100 full-text PDFs per topic, a parallel explore-exploit discovery loop, and a paper writer with a claim verifier that checks draft claims against logs, code, and bibliography before finalizing LaTeX. On the ADRS benchmark with 75 papers across 5 systems and 5 tasks, ScientistOne is the only system to achieve 0 hallucinated references, with 0 over 337 bibliography entries, perfect score verification at 12 over 12, and the highest method code alignment at 14/15. By contrast, baselines show hallucinated reference rates up to 21% and score verification as low as 42%. The paper also reports a native numerical claim provenance rate of 627/639, or 98.1%, and notes that the corrected rate is about 99%. On the solver side, ScientistOne matches or exceeds human experts on all 5 ADRS tasks and reaches 1.06 on parameter golf, where the baseline fails due to a 16 megabytes artifact limit. In broader transfer tests, it earns gold medals on 3D, object detection, and RSNA brain tumor, while scaling search width improves TXN by 17% to 4,255, and budget scaling improves it by 20% to 4,348. That's a wrap on today's AI paper highlights. Thanks for watching.